CIET NCERT presents audiobook Ganit Prakash, Part 2, Textbook of Mathematics for Grade 7.
Page number 24. Chapter number 2, Operations with Integers. On the right side of the page, we are provided with a QR code, scanning which we can reach out to the additional resources to this chapter. 2.1, a quick recap of integers. Rakesh's puzzle, a number game. Rakesh gives you a challenge. I have thought of two numbers, he says. Their sum is 25 and their difference is 11. Can you tell me the two numbers? You don't need to use any formulas. Just try different pairs of numbers and then check. First, do the two numbers add up to 25? Second, is the difference between them 11? Remember, the difference means first number minus second number. Write your guesses like this. We are provided with a tabular column having 4 rows and 4 columns. First column is for first number, second column is for second number, third column is for their sum, and fourth column is for the difference. First number is 10, second number is 15, their sum is 25 and difference is minus 5. Next, first number is 20, second number is 5, sum is 25 and difference is 15. Next, first number is 19, second number is 6, sum is 25 and difference is 13. Next, first number is 18, second number is 7, sum is 25 and difference is 11. Did you find the right pair? Now that you have found the correct pair, Rakesh gives you a second challenge. Think of two numbers whose sum is 25 but their difference is minus 11. Use the same method. Try different pairs of numbers and fill in the table again. You will notice that if you swap the numbers from the first puzzle, you get the answer to Rakesh's second puzzle. That is, the first number is 7 and the second is 18. Page number 25. Figure it out. Let us try to find a few more pairs of numbers from their sums and differences. A. Sum is equal to 27, difference is equal to 9. B. Sum is equal to 4, difference is equal to 12. C. Sum is 0, difference is equal to 10. D. Sum is equal to 0, difference is equal to minus 10. E. Sum is equal to minus 7, difference is equal to minus 1. F. Sum is equal to minus 7, difference is equal to minus 13. Choose a partner and take turns to play this game. In each turn, one of you can think of two integers and give their sum and difference. The other person must then figure out the integers. After some practice, you can perform this magic trick for your family members and surprise them. Carom coin integers. A carom coin is struck to move it to the right. Each strike moves the coin a certain number of units of distance rightwards based on the force of the strike. We are provided with a line marked with numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On 4, a carom coin is placed and an arrow is represented towards right on this number line. To begin with, the coin is at point 0. If the coin is struck twice, with the first strike moving it by 4 units and the second strike moving it by 3 units, what will be the final position of the coin? It is clear that the coin will be 4 plus 3 is equal to 7 units from 0. If the coin is struck twice and if the two movements are known, can you give a formula for the final position of the coin? If the first strike moves the coin A units to the right and if the second strike moves the coin B units to the right, then the final position is P is equal to A plus B, where P is the distance of the coin from the starting point 0. We have a picture with mark 0 and two positions for the coin, one covering distance A and the another covering distance B. Point P represents the final position of the coin. We also have a formula written as P is equal to A plus B above the picture. Page number 26. Now, suppose the coin can be struck to move it in either direction, left or right. Here we have a line with position 0 at the center and a carom coin is placed there. Two arrows representing left and right are marked above the carom coin. The coin is at 0. If it is struck twice, the direction of the two strikes may be the same or different. Can you give a formula for the final position of the coin? One way to do this is to consider different cases of the directions of the strikes. First, both are rightward. Second, both are leftward. Third, the first one is rightward and the second one is leftward. And fourth, the first one is leftward and the second one is rightward. An efficient way to model this situation is to use positive and negative integers. First, let us model the line on which the coin moves as a number line. Here we have a picture of a number line marked with 0 at the center and we have integers marked -1, -2, -3, -4, -5 so on towards the left on the number line and integers 1, 2, 3, 4, 5, 6 and so on marked towards the right side of the number line. Let us consider the rightward movement positive and the leftward movement negative. Suppose the first strike moves the coin rightward by 5 units from 0 and the second strike leftward by 7 units, then we take the first movement is equal to 5 units, second movement is equal to -7 units. What is the final position of the coin? This can be found by simply adding the two movements. 5 plus within brackets -7 is equal to -2. So, the coin is at -2 or it is 2 units to the left of 0. In general, if the first strike moves the coin A units, which is positive, if the strike is to the right, and negative if the strike is to the left. and the second strike B units, which is positive if the strike is to the right and negative if the strike is to the left. Then the final position P after the two strikes is again P is equal to A plus B. Based on this model, answer the following questions. First, if the first movement is -4 and the final position is 5, what is the second movement? Page number 27. Question number 2. If there are multiple strikes causing movements in the order 1, -2, 3, -4, so on, -10, what is the final position of the coin? By modeling the movements as numbers, both positive and negative, we are able to capture two pieces of information: the distance, magnitude, and the direction, rightward or leftwards. For example, when we say the movement is -4, the magnitude is 4 and the direction is leftward. From the figures given here, what can you conclude about the magnitudes of A and B compared to each other? And what are their directions? Remember to start from 0. In the first figure, the movement is A of the coin from 0 towards right. And from here, the coin moves distance B towards left, that is negative side, and reaches at position P. In the second figure, the distance moved is A from 0 towards positive side, and then it moves distance B towards left and reaches position P on the positive side of the number line. In the third figure, the coin is placed at P, which is at 0. Then it moves distance A towards negative side and then moves distance B towards right side to reach point P, which is at 0, its initial position. Page number 28. In addition to the number line, we use the token model to understand integers. We use this model to perform addition and subtraction in grade 6. Let us do a quick recall. We used green plus token to represent +1 and red minus token to represent -1, that is -1. Together, they make 0 as they cancel each other out. Find +7 minus within brackets +18. To subtract 18 from 7, that is +7 minus within brackets 18, we need to remove 18 positives from 7 positives. We have figure of 7 positive tokens here, which are green in color. But there are not enough tokens to remove 18 positives. We put in enough 0 pairs so that we can remove 18 positives. How many? We have 7 positives and we need 11 more. So we need to put in 11 0 pairs. Here in the picture, we can find that there are 18 positive tokens and 11 negative tokens. We can now remove 18 positives. What is left? There are 11 negatives, meaning -11. In the figure, we find that 18 positive tokens are removed and only 11 red tokens, which are negative, they remain. So, 7 minus 18 is equal to minus 11. We had also learnt that subtracting a number is the same as adding its additive inverse. Using tokens, argue out the following statements. A. 7 minus 18 is equal to 7 plus within brackets minus 18. Additive inverse of 18 is minus 18. B. 4 minus within brackets minus 12 is equal to 4 plus 12. Additive inverse of minus 12 is 12. Note to the teacher. Tokens of different shapes may be used for positive and negative numbers for visually challenged students. Page number 29. Additive inverse of an integer a is represented as minus a. So, the additive inverse of 18 is represented as minus 18 or minus within brackets 18. And the additive inverse of minus 18 is represented as minus within brackets minus 18, that is equal to 18. 2.2 Multiplication of integers. We use the token model to represent addition and subtraction of integers. We now explore how to model multiplication of integers using tokens. Suppose we put some positive tokens into an empty bag as given in the figure. How many positives are in the bag now? There are 8 positives in the bag. We can find this by adding 2 positives to the bag 4 times. Thus, the operation is 4 into 2 is equal to 8. We have learned this kind of multiplication of positive integers before. Can we use tokens to give meaning to multiplications like 4 into minus 2? Let us see how. For every new operation, we start with an empty bag. Here, in the picture, we find 2 green tokens forming a pair 4 times. Thus, in total, there are 8 green positive tokens. 2 green tokens 4 times is equal to 8. That is, 4 into 2 is equal to 8. Here there is another picture in which we find 2 red tokens forming a pair 4 times. There are in total 8 red negative tokens. 2 red tokens 4 times is equal to minus 8. 4 into minus 2 is equal to minus 8. Here 4 is a multiplier, minus 2 is the multiplicand, and minus 8 is the product. For every new operation, we start with an empty bag. 4 into minus 2 can be interpreted as placing 2 negatives into an empty bag 4 times. We use red tokens for negatives, so we place 2 negatives into an empty bag 4 times. There are now 8 red tokens or 8 negatives in the bag, meaning minus 8. 4 into minus 2 is equal to minus 8. Similarly, find the values of 4 into within brackets minus 6 and 9 into within brackets minus 7. How can we interpret within brackets minus 4 into 2? When the multiplier is positive, we place tokens into the bag. When the multiplier is negative, we remove tokens from the bag. So, for minus 4 into 2, we need to remove 2 positives or 2 green tokens from the bag 4 times. Page number 30. Why are we trying to remove green tokens and not red tokens? But there are no tokens in the bag. because we start with an empty bag. Just as in the case of subtraction, to remove two positives from an empty bag, we need to first place two zero pairs inside and then remove the two positives. We need to do this 4 times. Here in the picture, we find there are two zero pairs placed side by side 4 times. To explain that, removal of two green tokens from the zero pairs 4 times will give -8. That is 8 red tokens. Remove two green tokens from the zero pairs 4 times. So -4 into 2 is equal to -8. After removing the positives, 8 negatives are left in the bag. This is -8. This represents that -4 into 2 is equal to -8. What happens when both the integers in the multiplication are negative? How do we model -4 multiplied by -2 with tokens? For -4 into -2, we need to remove two negatives from the bag 4 times. Since there are no red tokens in the bag, we need to place two zero pairs and remove two negatives. And we need to do this 4 times. Here in the picture, we find there are two zero pairs placed side by side 4 times. To explain that, removal of two red tokens from the zero pairs 4 times will give 8, that is 8 green positive tokens. Remove two red tokens from the zero pairs 4 times. -4 into -2 is equal to 8. 8 positives are left in the bag, that is +8. So, -4 into -2 is equal to +8. So far, we have established the following results by using tokens. 4 into 2 is equal to 8. 4 into -2 is equal to -8. -4 into 2 is equal to -8. And -4 into -2 is equal to 8. Page number 31. Figure it out. Question number 1. Using the token interpretation, find the values of A. 3 into -2, B. -5 into -2, C. -4 into -1, D. -7 into 3. Question number 2. If 123 is multiplied by 456 is equal to 56,088, without calculating, find the value of A. -123 into 456, B. -123 into -456, C. 123 into -456. Question number 3. Try to frame a simple rule to multiply two integers. Consider the numbers represented by the following tokens. A. There are two minus red tokens. B. We have 4 minus red tokens and 2 green positive tokens. C. Here we have 6 negative red tokens and 4 green positive tokens. We can notice that all of them represent the numbers -2. Now, take 4 times each of these token sets. That is, place each set into the empty bag 4 times. What integer do we get as the final answer in each case? Do we get different answers because the sets look different? Or the same answer because they all represent -2? Check this for 5 into 4. By taking different token sets corresponding to 4. We have learned that minus 4 into 2 is the number obtained by removing 2 positive tokens from the empty bag 4 times. We know that removing or subtracting a number is the same as adding its inverse. Using this, can minus 4 into 2 be defined through a process of addition of tokens instead of removal of tokens? Page number 32. Here we find there are 8 negative red tokens placed in 4 pairs. Since removing 2 positive tokens is the same as adding 2 negative tokens, minus 4 into 2 can also be obtained by adding 2 negative tokens to the empty bag 4 times. Patterns in integer multiplication. We have explored the multiplication of integers in cases where the multiplier is positive, when it is negative, when the multiplicand is positive, and when it is negative. Using this understanding, let us construct a sequence of multiplications and observe the patterns. Here we have pattern of numbers written as 4 into 3 is equal to 12, 3 into 3 is equal to 9, 2 into 3 is equal to 6, 1 into 3 is equal to 3, 0 into 3 is equal to 0. In each subsequent step, we notice that there is a decrease of minus 3. 12 reduces to 9, 9 reduces to 6, 6 reduces to 3, and 3 reduces to 0. What do you notice in this pattern? Can you describe it? We can find that when the multiplicand is positive, for every unit decrease in the multiplier, the product decreases by the multiplicand. We have another pattern of numbers here. 4 into 3 is equal to 12, 3 into 3 is equal to 9, 2 into 3 is equal to 6, 1 into 3 is equal to 3, 0 into 3 is equal to 0, minus 1 into 3 is equal to minus 3, minus 2 into 3 is equal to minus 6, minus 3 into 3 is equal to minus 9. Here, we notice that at every subsequent step, there is a decrease of minus 3. 12 reduces to 9, 9 reduces to 6, and 6 reduces to 3, 3 reduces to 0, 0 reduces to minus 3, minus 3 reduces to minus 6, and minus 6 reduces to minus 9. Will this pattern continue when the multiplier goes below 0 and becomes a negative number? Yes, indeed. The same pattern continues when the multiplier becomes a negative number. What is the pattern when the multiplicand is a negative integer? 4 into minus 3 is equal to minus 12. 3 into minus 3 is equal to minus 9. 2 into minus 3 is equal to minus 6. 1 into minus 3 is equal to minus 3. And 0 into minus 3 is equal to 0. We notice that there is an increase of plus 3 at each subsequent step. Minus 12 increases to minus 9. Minus 9 increases to minus 6. Minus 6 increases to minus 3. And minus 6 increases to 0 by addition of plus 3 at every step. This is the inverse of the previous pattern. When the multiplicand is negative, for every unit decrease of the multiplier, the product increases by the multiplicand. Will this pattern continue when the multiplier goes under 0 and becomes a negative integer? Yes. Page number 33. Even when the multiplier is negative, the same pattern is observed. When the multiplicand is negative, for every unit decrease in the multiplier, the product increases by the multiplicand. We can find from these patterns that what is true for multiplication when the integers are positive is also true for the integers are negative. We have a pattern represented here as 4 into minus 3 is equal to minus 12, 3 into minus 3 is equal to minus 9, 2 into minus 3 is equal to minus 6, 1 into minus 3 is equal to minus 3, 0 into minus 3 is equal to 0, minus 1 into minus 3 is equal to plus 3, minus 2 into minus 3 is equal to plus 6, minus 3 into minus 3 is equal to plus 9. We notice that at every subsequent step there is an increase by plus 3. With this understanding of multiplication of integers, let us observe the times 3 tables when the multipliers and multiplicants are positive and when they are negative. We have 4 different columns here. The first one reads 1 into 3 is 3, 2 into 3 is equal to 6, 3 into 3 is equal to 9, 4 into 3 is equal to 12, 5 into 3 is equal to 15, 6 into 3 is equal to 18, 7 into 3 is equal to 21, 8 into 3 is equal to 24, 9 into 3 is equal to 27, and 10 into 3 is equal to 30. The second column reads minus 1 into 3 is equal to minus 3, minus 2 into 3 is equal to minus 6, minus 3 into 3 is equal to minus 9, minus 4 into 3 is equal to minus 12, minus 5 into 3 is equal to minus 15, minus 6 into 3 is equal to minus 18, minus 7 into 3 is equal to minus 21, minus 8 into 3 is equal to minus 24, minus 9 into 3 is equal to minus 27, minus 10 into 3 is equal to minus 30. And the third column reads 1 into minus 3 is equal to minus 3, 2 into minus 3 is equal to minus 6, 3 into minus 3 is equal to minus 9, 4 into minus 3 is equal to minus 12, 5 into minus 3 is equal to minus 15, 6 into minus 3 is equal to minus 18, 7 into minus 3 is equal to minus 21, 8 into minus 3 is equal to minus 24, 9 into minus 3 is equal to minus 27, 10 into minus 3 is equal to minus 30. And the fourth column reads minus 1 into minus 3 is equal to 3, minus 2 into minus 3 is equal to 6, minus 3 into minus 3 is equal to 9, minus 4 into minus 3 is equal to 12, minus 5 into minus 3 is equal to 15, minus 6 into minus 3 is equal to 18, minus 7 into minus 3 is equal to 21, minus 8 into minus 3 is equal to 24, minus 9 into minus 3 is equal to 27, and minus 10 into minus 3 is equal to 30. We observe the following. First, the magnitude of the product does not change with the change in the signs of the multiplier and the multiplicand. Second, when both the multiplier and the multiplicand are positive, the product is positive. Third, when both the multiplier and the multiplicand are negative, the product is positive. Fourth, when one of the multiplier or the multiplicand is positive and the other is negative, their product is negative. Figure it out. Find the following products. A. 4 into minus 3. B. Minus 6 into minus 3. Page number 34. C. Minus 5 into minus 1. D. Minus 8 into 4. E. Minus 9 into 10. F. 10 into minus 17. Consider the expression 1 into A. We know that the value of this expression is A for all positive integers. Is this true for all negative integers too? Using the token model, we put A negatives into the bag just once. After this, the bag contains A negatives. For example, if A is minus 5, that is 5 negatives, then the bag contains 5 negatives, that is minus 5. So, 1 into A is equal to A for all integers a, both positive and negative. What is the value of the expression minus 1 into a? When a is positive, then from our observations on integer multiplication, the product has the same magnitude as a but is negative. When a is negative, then the product has the same magnitude as a but is positive. In each case, we notice that the product is the additive inverse of the multiplicand a. Thus, minus 1 into a is equal to minus a for all integers a. In the case of integers, is the product the same when we swap the multiplier and the multiplicand? Try this for some numbers. Observe the following pairs of multiplications. Fill in the blanks where needed. Here we have 3 into minus 4 is equal to minus 12. Minus 30 into 12 is equal to dash. Minus 15 into minus 8 is equal to 120. 14 into minus 5 is equal to minus 70. Minus 4 into 3 is equal to minus 12. 12 into minus 30 is equal to dash. Minus 8 into minus 15 is equal to 120. Minus 5 into dash is equal to minus 70. What do you notice in these pairs of multiplication statements? The product is the same when we swap the multiplier and multiplicand. Earlier, we have noticed a similar property with addition. Will this always happen? The magnitude of the product does not change when the multiplier and the multiplicand are swapped. This is because the magnitude of the product depends only on the magnitude of the multiplier and the multiplicand. And we know that the product of two positive integers does not change when the numbers being multiplied are swapped. Page number 35. Does the sign of the product change if we swap the multiplier and the multiplicand? If both are positive or both are negative, the product is positive before and after swapping. So the sign does not change in this case. If one is positive and the other is negative, the product is negative before and after swapping. So the sign does not change in this case either. Hence, the product does not change when the multiplier and the multiplicand are swapped, whatever their signs may be. Thus, multiplication is commutative for integers. In general, for any two integers a and b, we can say that a into b is equal to b into a. Brahmagupta's rules for multiplication and division of positive and negative numbers. Just like for addition and subtraction of integers, Brahmagupta in his Brahmasputa Siddhanta 628 CE also articulated explicit rules for integer multiplication and division. He used the notions of fortune, dhana, for positive values and debt, rina, for negative values. In his Brahmasputa Siddhanta 18.30-32, Brahmagupta wrote, "The product or quotient of two fortunes is a fortune. The product or quotient of two debts is a fortune. The product or quotient of a debt and a fortune is a debt. The product or quotient of a fortune and a debt is a debt." This represented the first time that rules for multiplication and division of positive and negative integers were articulated and was an important step in the development of arithmetic and algebra. Example 1. An exam has 50 multiple choice questions. 5 marks are given for every correct answer and 2 negative marks for every wrong answer. What were Mala's total marks if she had 30 correct answers and 20 wrong answers? Solution. We use positive and negative integers. The mark for each correct answer is a positive integer 5 and for each wrong answer is a negative integer -2. Marks for 30 correct answers is equal to 30 into 5. Marks for 20 wrong answers is equal to 20 into -2. Thus, the arithmetic expression for 30 correct answers and 20 wrong answers is 30 into 5 plus 20 into -2. That is equal to 150 plus within brackets -40. That is equal to 110. Mala got 110 marks in the exam. Page number 36. What are the maximum possible marks in the exam? What are the minimum possible marks? Example 2. There is an elevator in a mining shaft that moves above and below the ground. The elevator's position over the ground are represented as positive integers and positions under the ground are represented as negative integers. A. The elevator moves 3 meters per minute if it descends into the shaft from the ground level 0. What will be its position after an hour? B. If it begins to descend from 15 meters above the ground, what will be the position after 45 minutes? Here, on the right side of the page, we are provided with a picture of an elevator with the markings on the elevator as 180 meters, 125 meters, 100 meters, 40 meters, 0 meters, -50 meters, -80 meters, -125 meters, and -175 meters. Solution. Solution to part A of the question. Method 1. We can model this using subtraction. The elevator moves at 3 meters per minute. So, in 1 hour, it moves 180 meters, 60 into 3. If it started at ground level 0 meters and descended, we should subtract 180 from 0. 0 minus 180 is equal to minus 180. So, it will reach the minus 180 meters position, which is 180 meters under the ground. Method 2. Let us say that the speed and direction of the elevator are represented by an integer meters per minute. It is +3 when it is moving up and it is -3 when moving down. Since the elevator is moving down, the speed is -3 meters per minute. It moves for 60 minutes. So, it goes 60 into -3 is equal to -180. Page number 37. The position of the elevator after 60 minutes is 180 meters below the ground level. Find the solution to part B using method 1 described here. Solution to part B using method 2. Starting position is equal to 15. Distance travelled is equal to elevator moves down at the speed of 3 meters per minute for 45 minutes. That is 45 into -3. So, ending position is equal to 15 plus within brackets 45 into -3. That is equal to 15 plus within brackets -45 into 3. That is equal to 15 plus within brackets minus 135. That is equal to minus 120. The elevator will be 120 meters below the ground. A magic grid of integers. A grid containing some numbers is given here. Follow the steps as explained until no number is left. We have 4 by 4 grid which reads the numbers as row wise: 8, minus 4, 12, minus 6, minus 28, 14, minus 42, 21, 12, minus 6, 18, minus 9, 20, minus 10, 30, minus 15. Instructions mentioned against this grid are: circle any number. Next, strike out the row and the column containing that number. Next, circle any unstruck number and repeat the step: strike out the row and the column containing that number. When there are no more unstruck numbers, stop. Multiply the circle numbers. An example is explained here. We have the same grid explaining the situation in 4 different rounds. After following the instructions of round 1, we find that the first row and the last column are struck. And in the second round, we find that when we select a number, we encircle number 14, we find that second row and second column are struck out. In third round, we find that when a number is circled in the fourth row, the first column and the last row are struck out. In the round 4, we find that only 18 number is left which is encircled. Page number 38. Try again and choose different numbers this time. What product did you get? Was it different from the first time? Try a few more times with different numbers. Play the same game with the grid given here. What answer do you get? We have same 4 by 4 grid here which reads the numbers row wise as 8, minus 4, 12, minus 6, minus 28, 14, minus 42, 21, 12, minus 6, 18, minus 9, 20, minus 10, 30, minus 15. What is so special about these grids? Is the magic in the numbers or the way they are arranged or both? Can you make more such grids? Division of integers. We have earlier learnt how division can be converted into multiplication. For example, minus 100 divided by 25 can be reframed as: what should be multiplied to 25 to get minus 100? That is, 25 into what number gives us minus 100? We know that 25 multiplied by minus 4 is equal to minus 100. Therefore, minus 100 divided by 25 is equal to minus 4. Similarly, minus 100 divided by minus 4 can be reframed as: what should be multiplied to minus 4 to get minus 100? Minus 4 into what number gives us minus 100? We know that minus 4 multiplied by 25 is equal to minus 100. Therefore, minus 100 divided by minus 4 is equal to 25. Similarly, we know that minus 25 into minus 2 is equal to 50. Therefore, 50 divided by minus 25 is equal to minus 2. Page number 39. Can you summarize the rules for integer division looking at the above pattern? In general, for any two positive integers a and b, where b not equal to 0, we can say that a divided by minus b is equal to minus within brackets a divided by b. Minus a divided by b is equal to minus within brackets a divided by b. And minus a divided by minus b is equal to a divided by b. Figure it out. Question number 1. Find the values of a 14 into minus 15, b minus 16 into minus 5, c 36 divided by minus 18, d minus 46 divided by minus 23. Question number 2. A freezing process requires that the room temperature be lowered from 32 degrees Celsius at the same rate of 5 degrees Celsius every hour. What will be the room temperature 10 hours after the process begins? Question number 3. A cement company earns a profit of 8 rupees per bag of white cement sold and a loss of 5 rupees per bag of grey cement sold. Represent the profit or loss as integers. A. The company sells 3,000 bags of white cement and 5,000 bags of grey cement in a month. What is its profit or loss? B. If the number of bags of grey cement sold is 6,400 bags, what is the number of bags of white cement the company must sell to have neither profit nor loss? Question number 4. Replace the blank with an integer to make a true statement. A. Minus 3 into dash is equal to 27. B. 5 into dash is equal to minus 35. C. Dash into minus 8 is equal to minus 56. D. Dash into minus 12 is equal to 132. E. Dash divided by minus 8 is equal to 7. F. Dash divided by 12 is equal to minus 11. Expressions using integers. What is the value of the expression 5 into minus 3 into 4? Does it matter whether we multiply 5 into minus 3 and then multiply the product with 4, or if we multiply minus 3 into 4 first and then multiply the product with 5? 5 into minus 3 within brackets into 4 is equal to minus 15 into 4, that is equal to minus 60. 5 into within brackets minus 3 into 4 is equal to 5 into minus 12, that is equal to minus 60. Page number 40. Take a few more examples of multiplication of three integers and check this property. What do you observe? We can notice that the product is the same when we group the multiplications in these two ways. So, integer multiplication is associative, just like integer addition. In general, for any three integers a, b and c, a into within brackets b into c is equal to within brackets a into b into c. In the expression 5 into minus 3 into 4, try to multiply 5 and 4 first and then multiply the product with minus 3. That is 5 into 4 within brackets into minus 3. 5 into 4 is equal to 20 and 20 into minus 3 is equal to minus 60. This also gives the same product. Are there orders in which 5 into minus 3 into 4 can be evaluated? Will the product be the same in all these cases? Multiply the expression 25 into minus 6 into 12 in all the different orders and check if the product is the same in all cases. The product remains the same when 3 or more numbers are multiplied in any order. Look at the following series of multiplications. Minus 1 into minus 1 is equal to 1. Minus 1 into minus 1 into minus 1 is equal to minus 1. Minus 1 into minus 1 into minus 1 into minus 1 is equal to 1. Minus 1 into minus 1 into minus 1 into minus 1 into minus 1 is equal to 1. When minus 1 is multiplied 2 or 4 times, the product is positive. When it is multiplied 3 or 5 times, the product is negative. Can you generalize these statements further? Using this understanding of multiplication of many integers, can you give a simple rule to find the sign of the product of many integers? Now consider the expression 5 into within brackets 4 plus within brackets minus 2. As in the case of positive integers, is this expression equal to 5 into 4 plus 5 into within brackets minus 2? We find that it does. Recall that we call this property the distributive property. Check if the distributive property holds for minus 2 into within brackets 4 plus within brackets minus 3. That is, if this expression equals minus 2 into 4 plus minus 2 into minus 3 and for a few other such expressions of your choice. What do you observe? We find that the distributive property seems to hold for integers as well. Will this always happen? Page number 41. In the case of positive integers, we used a rectangular arrangement of objects to visually understand why the distributive property holds. We can use the same setup even in the case of integers by using green tokens for positive integers and red tokens for negative integers. For example, consider the following rectangular arrangement of tokens. We find that the overall arrangement represents 4 into within brackets 2 plus minus 3 within brackets, and it is clear that this also equals the sum of 4 into 2 and 4 into minus 3. Here we are provided with a picture in which we find there are 8 green tokens which are arranged in 4 rows and 2 columns. Besides this, we have 12 tokens arranged in 4 rows and 3 columns which are negative. Above the picture, we have 4 into within brackets 2 plus within brackets minus 3. Below the green tokens, we have 4 into 2 written, and below the red tokens, we have 4 into minus 3 written below it. We find that the overall arrangement represents 4 into within brackets 2 plus minus 3, and it is clear that this is also equal to the sum of 4 into 2 and 4 into minus 3. Can you visually show the distributive property for an expression like minus 4 into within brackets 2 plus within brackets minus 3? Hint provided is use the fact that multiplying a number by minus 4 is adding the inverse of the number 4 times. Thus, for any integer a, b and c, we have a into within brackets b plus c is equal to a into b within brackets plus A into C within brackets. Pick the pattern. Two pattern machines are given here. Each machine takes 3 numbers, does some operations and gives out the result. Find the operations being done by machine 1. We have two pictures representing two different machines. In machine 1, we have some numbers, and in between these numbers there are some circles which are blank for the operations to be written in them. First one reads 5, blank circle 8, blank circle 3 gives 10. Next one 10, blank circle 11, blank circle 12 gives 9. 5, blank circle 8, blank circle minus 3 gives 16. Minus 3, blank circle 10, blank circle 2 gives 5. Minus 4, blank circle minus 1, blank circle minus 6 gives 1. Last one, minus 10, blank circle minus 12, blank circle minus 9 gives blank. Write the operations in the blank circles provided. Beside this, we have another picture in which machine 2 is written, and the numbers written are 4, blank circle 8, blank circle minus 3 gives minus 29. Next, 6, blank circle minus 11, blank circle 12 gives 54. Next, 5, blank circle 3, blank circle 7 gives minus 22. Minus 3, blank circle 9, blank circle minus 8 gives 35. Minus 7, blank circle 4, blank circle 6 gives 22. Minus 10, blank circle minus 12, blank circle minus 9 gives blank. You are supposed to fill up the operations in the blanks provided here. Page number 42. The operation done by machine 1 is first number plus second number minus third number. Written as an expression, this will be A plus B minus C, where A is the first number, B is the second number, and C is the third number. For example, 5 plus 8 minus 3 is equal to 10. And minus 4 plus within brackets minus 1 minus within brackets minus 6 is equal to 1. So, the result of the last group will be minus 10 plus within brackets minus 12 minus within brackets minus 9 is equal to dash. Find the operations being done by machine 2 and fill in the blank. Make your own machine and challenge your peers in finding its operations. Figure it out. Question number 1. Find the values of the following expressions. A, minus 5 into 18 plus within brackets minus 3. B, minus 7 into 4 into minus 1. C, minus 2 into minus 1 into minus 5 into minus 3. Question number 2. Find the values of the following expressions. A, minus 27 divided by 9. B, 84 divided by minus 4. C, minus 56 divided by minus 2. Question number 3. Find the integer whose product with minus 1 is A, 27, B, minus 31, C minus 1, D 1, E 0. Question number 4. If 47 minus 56 plus 14 minus 8 plus 2 minus 8 plus 5 is equal to minus 4, then find the value of minus 47 plus 56 minus 14 plus 8 minus 2 plus 8 minus 5 without calculating the full expression. Question number 5. Do you remember the Collard's conjecture from last year? Try a modified version with integers. The rule is start with any number. If the number is even, take half of it. If the number is odd, multiply it by minus 3 and add 1. Repeat. An example sequence is given here. Minus 7 gives 22, 22 gives 11, 11 gives 32, 32 gives minus 16, minus 16 gives minus 8, minus 8 gives minus 4, and minus 4 gives minus 2, minus 2 gives minus 1, minus 1 gives 4, 4 gives 2, and 2 gives 1, and 1 again gives minus 2 in the picture given here. Page number 43. Try this with different starting numbers minus 21, minus 6 and so on. Describe the pattern you observe. Question number 6. In a test, plus 4 marks are given for every correct answer and minus 2 marks are given for every incorrect answer. A. Anita answered all the questions in the test. She scored 40 marks even though 15 of her answers were correct. How many of her answers were incorrect? How many questions are there in the test? B. Anil scored minus 10 marks even though he had 5 correct answers. How many of his answers were incorrect? Did he leave any questions unanswered? Question number 7. Pick the pattern. Find the operations done by the machine given here. We have a picture in which we have set of numbers 4, blank circle 8, blank circle minus 3 gives 28. Next row 6, blank circle 9, blank circle 6 gives minus 48. Next line 2, blank circle 3, blank circle minus 2 gives 8. Next minus 9, blank circle 5, blank circle minus 8 gives 31. Next line 7, blank circle minus 4, blank circle minus 6 gives minus 17. Last line minus 16, blank circle minus 6, blank circle minus 9 gives blank. Question number 8. Imagine you are in a place where the temperature drops by 5 degrees Celsius each hour. If the temperature is currently at 8 degrees Celsius, write an expression which denotes the temperature after 4 hours. Question number 9. Find 3 consecutive numbers with a product of A. minus 6, B. 120. Question number 10. An alien society uses a peculiar currency called pibs with just 2 denominations of coins, a plus 13 pips coin and a minus 9 pips coin. You have several of these coins. Is it possible to purchase an item that cost plus 85 pips? Page number 44. Yes, we can use 10 coins of plus 13 pips and 5 coins of minus 9 pips to make a total of plus 85. Using the two denominations, try to get the following totals: A plus 20, B plus 40, C minus 50, D plus 8, E plus 10, F minus 2, G plus 1. Hint provided is, writing down a few multiples of 13 and 9 can help. H. Is it possible to purchase an item that cost 1568 pips? Question number 11. Find the values of A. 32 into minus 18 within brackets divided by minus 36. B. 32 divided by minus 36 into minus 18 within brackets. C. 25 into minus 12 divided by 45 into minus 27 within brackets. D. 280 into minus 7 within brackets divided by minus 8 into minus 35 within brackets. Question number 12. Arrange the expressions given here in increasing order. A. Minus 348 plus within brackets minus 1064. B. Minus 348 minus within brackets minus 1064. C. 348 minus within brackets minus 1064. D. Minus 348 into within brackets minus 1064. E. 348 into within brackets minus 1064. F. 348 into 964. Question number 13. Given that minus 548 into 972 is equal to minus 532656, write the values of A. Minus 547 into 972. B. Minus 548 into 971. C. Minus 547 into 971. Question number 14. Given that 207 into minus 33 plus 7 within brackets is equal to minus 5382, write the value of minus 207 into within brackets 33 minus 7 is equal to dash. Question number 15. Use the numbers 3, minus 2, 5, minus 6 exactly once and the operations plus, minus and multiplication exactly once and brackets as necessary to write an expression such that A. The result is the maximum possible. B. The result is the minimum possible. Question number 16. Fill in the blanks in at least 5 different ways with integers. A. Blank plus blank into blank is equal to minus 36. B. Within brackets blank minus blank into blank is equal to 12. C. Blank minus within brackets blank minus blank is equal to minus 1. Page number 45. Summary. First point. When two integers are multiplied, the product is positive. When both the multiplier and multiplicand are positive, or when both are negative. the product is negative if one of them is positive and the other is negative. Second point, when two integers are divided, the quotient is positive when both the dividend and the divisor are positive, or both are negative, the quotient is negative when one of them is positive and the other is negative. Next point, integer multiplication is commutative. That is, for any two integers a and b, a into b is equal to b into a. Next point, integer multiplication is associative. That is, for any three integers a, b and c, a multiplied by within brackets b into c is equal to within brackets a into b into c. Next point, integer multiplication is distributive over addition. That is, for any three integers a, b and c, a multiplied by b plus c is equal to within brackets a into b plus within brackets a into c. We are also provided with a grid here which reads -9, -6, -3, 3, 3, 6, 9, -6, -4, -2, 2, 2, 4, 6. Third row, -3, -2, -1, 1, 1, 2, 3. Fourth row reads -3, -2, -1 into 1, 2, 3. Next row reads 3, 2, 1, 1, -1, -2, -3. Next row reads 6, 4, 2, 2, -2, -4, -6. And the last row reads numbers 9, 6, 3, 3, -3, -6, -9. Puzzle time. Taruchu. Taruchu is a game played in Assam and Nagaland. The board has 16 squares and diagonals are marked as given in the following figure. This is usually roughly scratched on a large piece of stone or just drawn on mud. There are two players and each player has a set of 9 coins placed as given. The coins in the one set look different from those in the other set. Page number 46. Here, a picture of a square grid with some triangles is represented and coins have been placed in the order 5, 3, 3, 5 and 1 coin are each placed on both the sides of the squares. Objective is the goal is to capture all the opponent's coins. The first player to do so is the winner. A player may also win by blocking any legal move by their opponent. If a draw seems unavoidable, the player with more coins wins. Gameplay. First point, the starting position of the game is as given here. Second, players take turns. In each turn, they can move a single coin along a line in any direction to a neighboring vacant intersection, or if an opponent's coin is at the neighboring intersection and there is a vacant intersection just beyond it, they can jump over the opponent's coin and land in the vacant intersection. Third point, if a player jumps over an opponent's coin, it is considered captured and is removed from the board. Multiple captures in one move are allowed, and the direction can change after each step. Last point, inside the triangular corners, which are outside the main square, a coin may skip an intersection and move straight to the next one. That is, it can jump over an empty intersection and go to the one beyond it. We also have a picture of small kids wondering at the game and they desire to play it. Chapter 2 ends here.
Ganit Prakash, Part 2. You were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Manju Kumari. Assistance in production, Soumya Malik. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.